Out in the open water, a decommissioned very large crude carrier looks like a floating liability. But once hazardous materials are carefully purged, it becomes a highly concentrated cache of raw resources. Slicing open the hull reveals the sheer volume of material inside. Stripped of toxic elements, the ship represents the world's richest above-ground iron ore mine. To yield the 35,000 tons of pure steel contained in a single vessel, global operations would excavate and process over 100,000 tons of raw earth. Digging and crushing that virgin ore requires massive terrestrial destruction and intensive fuel combustion. These shorelines function as highly orchestrated industrial engines, geared toward the creation of new building materials. Moving inland, the deconstruction relies on a heavy industrial choreography. Crawler cranes drag 50-ton severed blocks of the superstructure away from the surf. In the primary cutting zone, workers rely on heavy manual labor, using oxyacetylene torches to slice straight through the towering steel bulkheads. Once those massive chunks reach the secondary cutting pads, the objective narrows. Cutters systematically strip away the lighter internal framing to isolate the thick, premium-grade hull plating that commands the highest value on the scrap market. A well-organized recycling yard operates with relentless, blistering speed, reducing a massive bulk carrier into neat, transportable steel slabs in less than 6 months. The pace is dictated by the flatbed trucks waiting at the gates. As soon as a stack is cut to size, it is chained down and immediately driven out into the dust. Piece by piece, the vessel drives away from the beach, circulating directly into the arteries of the global economy. Those trucks travel to sprawling, intensely hot industrial complexes across South Asia, the re-rolling mills. These facilities are calibrated to process thick, marine-grade plates. Western recycling traditionally dumps scrap into an electric arc furnace for a total liquid melt. Here, workers use an energy-efficient alternative, known as the direct rolling method. Instead of melting the steel, long tongs push the rectangular ship slabs into roaring reheating furnaces. The metal is heated precisely to the point of extreme malleability. The radiant, glowing plates are fed into heavy, spinning mechanical rollers. The extreme compression stretches the thick slabs directly into lengths of construction rebar. By skipping the energy cost of a complete liquid melt, this technique preserves the original, high-quality metallurgical strength engineered by the shipbuilders decades ago. A traditional blast furnace generates 1.8 tons of carbon dioxide for every ton of new steel. Re-rolling salvaged ship steel slashes those emissions. Scaled up globally, the ship recycling industry prevents 20 million tons of carbon dioxide from entering the atmosphere every year. The metal hull itself is only a fraction of the yield. Just a few miles inland along the highways sit the machinery bazaars, retail hubs that trade in the secondary maritime economy. Everything unbolted before the cutting torches arrived is sold here. Robust, over-engineered components like massive backup diesel generators are repurposed to provide reliable electricity to rural hospitals and textile factories. Every light bulb, galley oven, and navigation wheel finds a buyer. This zero-waste economic thoroughness honors every ounce of capital originally poured into the vessel's construction. Zooming out, the millions of tons of newly forged rebar rolling out of these mills are immediately absorbed by the expanding economies of the global south. The high-tensile steel harvested from a retired Norwegian crude oil tanker is now tied into the concrete forms of a massive highway overpass in Dhaka. A few hundred miles away, the metal from a decommissioned American container ship provides the skeletal framework for a new high-density residential high-rise in Mumbai. These ascending nations rely on this continuous pipeline of low-carbon material. Without it, their rapid urbanization and infrastructural expansion would severely stall. Steel that spent a quarter-century battling the oceans is brought ashore, heated, stretched, and permanently embedded into the concrete pillars holding up the sky. The global shipping fleet is resurrected on these beaches, transforming into the architecture of modern cities. As a researcher in naval architecture, my work revolves around mapping and quantifying this exact circular economy. As an Indonesian, I look closely at my own context. My country is a vast archipelago possessing one of the largest domestic commercial fleets in the world. This raises a vital question. Why do we send our aging ships thousands of miles away instead of capturing their economic value here at home? The multi-purpose shipyards of Indonesia are already preparing the infrastructure to launch a safe, highly regulated domestic shipbreaking industry. By adopting strict containment rules and cleaner production methods, we can capture this supply chain directly in our own backyard. Join me in Episode 7, where we examine how Indonesia is positioning itself to support a domestic model of maritime sustainability.